Okay, let's have a look here. So since x is between 0 and 1, that means we can use a Maclaurin series to say that 1 over 1 minus x equals 1 plus x squared plus x cubed plus x4, etc. And it doesn't have to be between 0 and 1, but we can also use a Maclaurin series to express ex as 1 plus x squared over 2 plus x cubed over 3 factorial plus x4 over 4 factorial. If we sub that all in, that means we're required to prove that 1 plus x is less than 1 plus x squared over 2 plus x cubed over 3 factorial, etc., which is less than 1 plus x squared plus x cubed, etc. Subtracting 1 from each expression and subtracting x from each expression means we need to show that 0 is less than x squared over 2 plus x cubed over 3 factorial, etc., which is less than x squared plus x cubed, etc. And this is true for two reasons. Since number one, x is positive, so that gives us the left side that x squared over 2 plus x cubed over 3 factorial, etc. is more than 0. And number two, it's also true since xn over n factorial is less than xn, where n is greater than or equal to 2. That gives the right that x squared over 2 plus x cubed over 3 is less than x squared plus x cubed, etc. Now, if you want to see that a little bit clearer, you could write down all the inequalities. X squared over 2 is less than x squared. X cubed over 3 is 3 factorial is less than x cubed. You can write them all out and add them up. So you do get then the situation on the left is less than the situation on the right. So, you can, if you want to elaborate a bit more, you can do it like this. So you might be asking, why do we need the less than 1 then? Well, you needed the less than 1 so that you could actually put in the substitution to begin with, but you didn't need it to be less than 1 for these two requirements, but you did need it to be less than 1 and more than 0 so you could make the substitution to begin with. So that's why the question confines x to be between 0 and 1 and not simply say that x is positive.